Welcome everyone on behalf of OPWA. I would like to thank all attendees for taking interest in today's webinar, and this is going to be a good one. Today's webinar is titled EV Charging Stations for Beginners. It's being organized by the OPWA Educational Committee. My name is Alexander Andrikov. I am with Halton Region, and I'll be your host for today. So a really quick overview of OPWA for those folks who maybe are new to the organization. It's a not-for-profit it's a not-for-profit organization of professional public work practitioners. The Ontario chapter is one of 63 chapters that makes up the American Public Works Association. We have over 500 members who are employed by provincial governments, municipalities, consultant engineers, utility companies, contractors, and suppliers. So the Ontario chapter itself, it's actually supported with two regional branches. We have the West Central branch down there in Southern Ontario and the Ottawa Valley branch up to the north. OPWA is a big organization. There's a lot to cover, but basically there's tons of committees you can attend if you are interested in volunteering, advocacy, awards, communications, and so forth. The overall mission statement for OPWA is all about connecting the public works community. Again, everyone from municipal to private, all across the board. It provides opportunities to members to connect through workshops, conferences, and social events. There are about, again, 9 committees that we noted right there to the side. If you're not a member of OPWA, we do encourage you to consider joining. And if interested, you can go on our website and find out more. The website is right down there, ontario.apwa.org. So here's a little bit of a list of future upcoming webinars. So on August 27th, we have the benefits of BIM with Parsons. And then on September 24th, it's changes to the CCDC contract. So both should be very interesting and good discussions. Now, a big thank you, of course, to our sponsors. I have them all up here on the page. Going kind of from on the top, we got the bronze sponsors in Robinson and Chisholm, MTS Silver, and under gold, we've got SEMA Plus, Joe Johnson Equipment, WSP, WT Infrastructure, RVA, Furpal, and RJ Burnside. Alrighty, so for today's webinar, all microphones will be muted and cameras will remain off. The questions will be addressed at the conclusion of the webinar. If you do have questions, go in the little Q&A box and type it in, and it'll be answered once the presentation is done. The webinar duration is about 1 hour, so we'll be done closer to 1 o'clock Eastern Standard Time. So a little bit about our wonderful presenters here. So to the right of the screen, there's Brent Pumple. Sorry, the purple shirt kind of give me a slip, but so he's a senior director at Pedestal Solutions Incorporated. He has about 15 years in the construction planning industry, spanning diverse roles from field work to estimating and designing. At Pedestal Solutions, Brent now specializes in crafting design-build solutions for electrical pedestals. Now, Joe Pumple, the operations manager at Vulcan, has about 7 years of experience as a technical research lead for the Performance and Available Computing Systems Lab at the University of Alberta. Joel helps deliver critical infrastructure backup battery chargers and related technologies at Vulcan Electric. So the presentation,
Perfect.
Skip there real quick. So the webinar will deliver a structured overview of EV charging station fundamentals, current funding opportunities, and the application steps required to assess federal, provincial, and utility sponsor grants. With the accelerated shift in electrified transportation, municipalities are in a strategic position to lead public and fleet charging solutions, and in educating city planners and developers on best practices for future EV expansion. Our webinar will provide a guide through applying for and securing grants to install EV charging infrastructure. We will show real-world case studies and discuss brand new technologies to demonstrate some successful municipal approaches to solving the shift to EVs. Whether your city is planning its first level 2 station or looking to scale up fast charging hubs, This session will provide the fundamental and foundational knowledge and planning framework necessary to get started confidently and effectively. All right, so with that, I do turn this webinar over to presenters, and welcome.
Okay, so hopefully you guys can hear me and see our screen there. We are presenting from just outside of Keswick, about 15 minutes out of Keswick, Highway 48 in Ravenshoe, and we're at my shop. So if there are some background construction sounds that happen, I just want to apologize in advance. Okay, so hi everybody, thanks for joining us today. Joel and I are really excited to share this talk with you guys.
We're going to dive right into EV charging stations and what they mean for public work professionals like yourselves.
Feel free to save your questions till the end, guys. We'll have plenty of time for Q&A as long as we keep up our pace. Okay, I'm going to take the lead there. Thank you very much, Alex, for that intro. Essentially, that is exactly what was read off here, so I'm going to save us a bit of time and skip over this slide, just talking about what we're going to talk about today. Okay, so for chapter 1, let's cover the EV charging basics. We're going to talk about EV adoption trends in Canada, the 3 different types of chargers, level 1, level 2, and level 3 DC fast charging. And lastly, we're going to talk about fleet versus public charging needs. Okay, so let's talk about what's happening with the electric vehicle adoption across Canada and why that matters for every municipality. The numbers tell us an incredible story. According to S&P Global's latest study, ZEVs, which is zero emission vehicles, jumped from 10% of new car registrations in 2023 to 15% in 2024, hitting 19% in Q4 of 2024. Right now, every 1 in 6 new vehicles registered in Canada is a zero emissions vehicle. Quebec shows us the way forward, achieving a 33% zero emissions vehicle adoption for all new registrations and accounting for 54% of all of Canada's zero emissions vehicles. The transition from internal combustion engines to electric vehicles isn't something we need to plan for anymore. It's happening right now. We have learned that economics and incentives drive this adoption. When Quebec's rebates dropped from $7,000 to $4,000, zero emission vehicle sales plummeted by 65% month over month. This tells us that municipalities offering affordable public EV charging solutions will have a significant competitive advantage in attracting growth. Municipalities are already leading by example. Cities like Calgary, North Battleford, and Kingston have begun transitions with electric garbage trucks, hybrid pickups, and fully electric equipment. The return on investment for fleet electrification is now crystal clear. There are several different online platforms that exist right now that will help you calculate your savings and make projections for making this switch happen. Infrastructure remains the foundation of success. Public works leaders need to prioritize electrical system upgrades and collaborate with utilities on robust charging solutions. Fleet charging technology has advanced significantly, now delivering both sustainable operations and genuine cost savings. Smart grid technology is the real game changer. As an example, let's talk about the UK's Kraken Power Authority, which shows its customers real-time energy rates. And with 30% of UK's power coming from wind generation, residents have learned that with windy days means lower rates. So they've started timing their household electrical use and car charging for those windy periods. This has saved everyone money and reduced peak grid demand. As you consider your municipality's path forward, research software solutions that meet your immediate needs while positioning you for future demands. The transformation is already underway. The question is whether we will lead it or follow it. Okay, the global EV shift is accelerating rapidly as well. Electric vehicles now represent over 20% of the worldwide car sales, following record growth through 2024 and 2025. We've identified a 5% tipping point, and it is showing to be a critical moment where once 5% of all vehicles on the road become electric, the entire transition seems to accelerate. At this threshold, we're noticing that plug-in hybrid sales drop sharply, along with their resale value, as consumers stop hedging their bets and go all electric. The challenge? Oftentimes, the urban infrastructure isn't ready. Condos, dense cities with street parking, and areas without proper charging infrastructure are getting caught off guard by this sudden demand. A common trend we are seeing work in building the infrastructure now, but planning ahead for battery-based EV charging integration. By incorporating in the rough-ins now for future battery buffered charging. Doing this, you achieve 3 key benefits. You slash utility demand charges, you avoid costly grid upgrades, and you maintain a high vehicle availability during peak hours. This is all about operational resilience, cost efficiency, and scalability in one smart approach. The transition is already happening. Will your infrastructure be ready for it? Okay, now let's break down the 3 types of EV chargers and why your choice matters. There's level 1, which maxes out at 1.9 kilowatts, which is a typical standard 120 volt connection at 16 amps. Basically your standard household outlet. Level 2 maxes out at 19 kilowatts, which can be powered on a standard 240 volt connection at 80 amps. That is 10 times the power output. And then we have level 3, which is 350 kilowatts or greater, basically no ceiling. We are talking about over 500 amps of power at 1,000 volts. We believe level 2 is a strategic choice. Here's why. Level 2 hits the perfect balance of speed, cost, and infrastructure needs. Level 2 chargers run on typical 240 volt power, but deliver 19 kilowatts, which translates to 90 to 100 kilometers of range per hour. For fleet operations, you already know your daily range requirements, so this works perfectly. There's a cost advantage. Installations for level 2 chargers run under $1,000 per unit. Compare that to $40,000 to $100,000 for level 3 chargers. Smart operations. You avoid those crushing demand charges that come with fast chargers. Plus, you can schedule charging during off-peak hours and save on electricity costs while also reducing grid strain. They're dual purpose. Level 2 works for both fleet needs and public needs. The bottom line, we believe level 2 gives you the right mix of performance, cost efficiency, and flexibility. It's perfect for fleet operations, public access, and scalable infrastructure development without all those headaches of high voltage installations. All right, let's talk about your electrical infrastructure right from the start. First things first, you need to know what you're working with. Calculate your existing electrical capacity, and if you're going to need more power down the road, plan for it now. The smart money is on a modular design that can scale up as needed. It's important to build relationships with your local power authority. Currently, Ontario utilities like Toronto Hydro, Electra, and Hydro One already have made this easier with interactive maps that show you feeder level and neighborhood load availabilities. These tools can save a lot of time. You're also going to need an accurate estimate of your total costs. And luckily there's websites with tools that will calculate that. They will calculate your anticipated costs, show you local funding options, and project your return on investment based on your specific set of choices. These are great tools to help with getting the budgeting approved. They clearly demonstrate the long-term return on investment of switching from gas to electric vehicles. And load management. The smart charging software that exists varies greatly. You're going to have to do your homework. There are many options out there, but getting the right one that meets all your needs is crucial. Our advice is to consider hiring a consultant and running pilot projects before you move to a large-scale implementation. Okay, now let's talk about fleet versus public charging and those key differences. Currently, commercial vehicles represent just 20% of all the vehicles on the road, yet they create over 60% of all road transport emissions. When we nail fleet electrification, we're showing the path forward for everyone. Here are 5 key differences between public and fleet-based charging. Control and predictability. Fleet charging gives you complete control. You schedule during off-peak hours, manage energy demand, and use smart systems to slash costs while avoiding utility demand charges. Public charging, it's like the Wild West. Vehicles show up randomly, you bear all the infrastructure and maintenance costs, and you have zero scheduling control. Infrastructure and scale investment. Fleet systems need high capacity installations and substantial electrical upgrades. Public networks tend to grow incrementally, usually just a few chargers at a time based on location and the estimated return on investment. The bottom line is having a clear electrification plan with implementation procedures is a crucial component. Reliability matters. I can tell you that. Joel and I both own electric vehicles and plug-in hybrids, and pulling up to a charging station that is down can be very difficult. Fleet vehicles, on the other hand, run on schedules. Unreliable charging creates operational bottlenecks, so uptime is critical. Plan your charging locations and power output for current and future fleet demands. Public station reliability varies wildly. Unpredictable availability and failed charges are common pain points. These are solvable problems, but they require planning and teamwork to build networks that truly serve your community. Well, guys, I just want to say thank you so much for listening to Chapter 1. That concludes it. I am now going to bring in Joel to read Chapter 2 and continue this presentation. Thanks, guys.
Okay. Yes, thank you again for taking time out of your day for this webinar, and I'm just going to jump right into it. With the federal goal of installing 84,500 chargers by 2029 and the need for 40,000 public ports annually from 2025 to 2040, we're looking at unprecedented funding opportunities. But here's the reality. Success in this space isn't just about knowing these programs exist. It's about being strategic, prepared, and understanding that this is a marathon, not a sprint. I'm going to cover a general overview of the current landscape for electric vehicle charging infrastructure funding available to municipalities within Ontario. I will also provide a general overview of the application process for each funding source covered and briefly review some recent success stories within some of the mentioned funding sources. As you will see in the next few slides, the 2 biggest funding sources are currently closed, with some promise to open again soon. So before you chase EV charging funding, consider this, the Municipal Energy Plan program. It could be your smartest first move. This program offers 50% funding for comprehensive energy planning with a maximum budget of $90,000 for new plans and $25,000 for updates to existing plans. These costs can cover anything from energy assessments to mappings to strategic frameworks related to the project. The plan you construct through this program will create the strategic foundation that makes you competitive for larger EV infrastructure funding sources. Instead of applying blindly for EV charging programs, you'll have data-driven plans showing exactly where charging infrastructure fits your community's energy future. Use the developed strategies from this program when applying for Charge On, Zero Emissions Vehicle Infrastructure Program, or the Green Municipal Fund programs. Funders want integrated sustainability strategies, not standalone projects. The bottom line here is a $45,000 municipal investment could unlock hundreds of thousands of dollars in infrastructure funding. Start here, build your foundation, and then pursue bigger opportunities with confidence. Now to dive into some of the larger provincial funding sources. I'll start with the currently open options. The Regional Development Program has an economic development focus that can include EV infrastructure. This program could cover up to 50% of eligible project costs to a maximum of $1.5 million per project. This program can be used to fund public EV charging stations, which is important to note as most of the currently open funding sources are restricted to fleet electrification. The Ontario Transit Investment Fund is one of the open sources restricted to municipal fleet electrification and transit charging infrastructure. In saying that, it has an annual funding pool of $5 million with a project timeline limit of 5 years. The advantage here is you don't have to reapply each year and instead can focus on completing the project in the given time window. Although the EV Charge On program is currently closed, it has recently received top-up funding in the amount of roughly $92 million, taking the total budget to nearly $190 million. This indicates a strong possibility that the program will reopen in the near future. The EV Charge On program helps smaller communities get EV charging stations through government funding. In order to apply, you need to own the property or get written permission from the owner and/or band council to run the charging stations for at least 5 years. The program is only for communities with populations of less than 170,000. Also, the resulting charging stations from the project must be open to the public for 24/7. There are requirements for the amount of charging ports to be available. Each station that have level 2 chargers must use standard SAE J1772 connectors, while at least 25% of the level 3 connectors must be CCS type. I have a small graphic on the slide here showing the most common connectors encountered at EV charging stations. For the most current information about when applications might reopen, I'd recommend checking the Ontario government's official EV Charge On program page or contacting the Ministry of Transportation directly. Moving on to some federal funding sources, I'd like to start with another planning support program, the Municipal Asset Management Program. Once you secure funding and install charging stations, you own them for decades. This program builds your capacity to properly manage, maintain, and plan replacement cycles for EV infrastructure assets. Funders increasingly want to see asset management plans in applications. They're not just buying you chargers, they're investing in 20+ year infrastructure. Demonstrating a strong asset management capacity strengthens your funding applications. The bottom line here is EV charging infrastructure isn't just about installation, it's about lifecycle management. Build this capacity now to strengthen future funding applications and ensure long-term success of your investments. Next, we will cover the Green Municipal Fund. This is partially because we need to get creative during this time window between the two larger funding sources being closed. Therefore, now is a good time to begin moving towards electrifying at least a portion of any existing municipal fleet vehicles and installing the required charging infrastructure. These projects can act as great pilot projects for larger public-facing EV charging solutions. In fact, this fund offers increased support for pilot and planning projects with 50 to 80% cost coverage, whereas for capital projects, they run on more of a loan style with a certain portion of that loan acting as a grant. The largest EV charging program available, the Zero Emissions Vehicle Infrastructure Program, as mentioned, is currently closed, but again, based on its current and projected results, it will likely resurface again at some point in the future. Nonetheless, this program provided up to 50% contribution to a maximum of $5 million per project. Best to be prepared in the event that a large federal-based program like this surfaces again. To stay on the Zero Emissions Vehicle Infrastructure Program, Toronto has had repeat success in this program, resulting from roughly $25 million over 2 years, projected to produce over 3,000 chargers, mostly level 2 and a quarter or so public facing. This is a part of their ongoing efforts to meet a zero emissions goal by 2050. It's important to note that Toronto used a multi-stream approach, including repeat applications to the same source, running workplace charging pilots, and installing street parking charging stations. Through this process, they entered the EV charging world from a fleet, public, workplace, and residential perspective. This demonstrates the value of pursuing multiple funding streams. It is worth mentioning the IV charging network. a combined effort between the Ontario Power Generation and Hydro One, resulting in one of the province's largest fast charging networks. This is just a great example of recent investment and development at the provincial scale. Now to briefly go over the application process for each of the funding sources I mentioned. Starting with the Municipal Energy Plan program, all Ontario municipalities can apply year-round for this program through the Transfer Payment Ontario portal. Lower tier municipalities need upper tier support letters, and there's a 50% matching funding requirement. Indigenous communities have their own separate program to apply through the IESO, the Independent Electricity System Operator. Now let's talk about the Regional Development Program. This one's actually still open, which is great news. Here's how it works. They have 4 application windows throughout the year, so you've got multiple chances to apply. But here's the catch. Before you can even submit your application, you need to have a mandatory sit-down with one of their regional advisors. Think of this as a pre-screening meeting to make sure you're on the right track. Once you do submit, they're pretty good about timelines. You'll get a decision within about 60 business days, which is reasonable compared to some other programs that can drag on. A couple of things to keep in mind. You'll need to register for something called TPON. That's just their internal system requirement. And this program also has geographic restrictions. It's only available to Eastern and Southwestern Ontario. So if you're in the GTA or Northern Ontario, unfortunately, this one won't work for you. The nice thing about having 4 application periods is that if you miss one deadline or need more time to prepare, you're not waiting the whole year for the next opportunity. The Ontario Transit Investment Fund, and it's currently open for applications. This program is a bit different from the others because there's no standard online application portal. Instead, you need to reach out directly to the Ministry of Transportation to get the ball rolling on the application process. So it's more of a conversation-based approach rather than filling out online forms. What's really attractive about this fund is the commitment level. They're offering funding agreements for up to 5 years. That's huge if you're planning a large-scale project because you get that long-term funding certainty instead of having to reapply each year. The focus here is specifically on transit services and fleet electrification. So if you're a transit authority looking to electrify your bus fleet, or you're involved in transit infrastructure more broadly, this could be a perfect fit. Since it's contract-based, I'd recommend reaching out sooner rather than later to understand their current priorities and timelines. These types of programs sometimes have informal deadlines for even though when they say they're open. Again, although it is closed, I'd like to go over it as well because it might open again in the future. The application process for the Charge On program is a competitive process where you submit details about your property, the charging equipment you plan to install, the cost estimates with your contractor quotes. If you're approved, you get rebates after construction is finished, but you must complete the project within 24 months. What happens after? You need to send annual usage reports for 5 years after installation. This helps track how well the program is working and ensures the charging stations are being used effectively in communities across the province. Okay, now the Green Municipal Fund. It uses a 2-stage application process. This actually is pretty straightforward. You start with a quick pre-screening application through their online portal. They get back to you within 15 business days. If you pass that screening, they invite you to submit a full application. The funding is generous, grants for planning and studies, plus loans combined with grants for bigger capital projects, sometimes up to $10 million in total. They accept applications year-round, which is convenient for municipal planning cycles. The review takes 3 to 6 months and focuses on environmental impact, innovation, and financial viability. There are external experts that do peer reviews to ensure quality projects are getting funded. Here's another good one that's also open, the Municipal Asset Management Program, the earlier one I mentioned for planning. This one runs through the Federation of Canadian Municipalities, or FCM, so you'll be applying directly through them rather than the province. What's nice is they have ongoing intake, which means there's no mad rush to hit a specific deadline. You can apply when you're ready. The focus here is on asset management capacity building. So this isn't necessarily about buying EV charging stations, but more about helping municipalities get better at managing their infrastructure assets, things like planning, data systems, and long-term maintenance strategies. This is part of a pretty substantial 8-year, $110 million program that FCM is administering. So there's real money behind it, and it's designed to be around for the long haul, which gives you confidence that this funding won't suddenly dry up. If you're a municipality that needs to get your asset management house in order before taking on new EV infrastructure projects, this could be a great stepping stone. It's often easier to get funding for planning and capacity building in the planning and capacity building phase first, and then use those as foundations to apply for the actual infrastructure funding later. The last application process to cover is again closed, but for similar reasons, important to review. Applications for the Zero Emissions Vehicle Infrastructure Program go through the Transportation and Fuels Decarbonization Program portal. You'll need to create a G key for secure access. This is a one-time setup, and then follow the system prompts. Only one user can manage each application. Your application package needs a detailed project proposal, technical specs, cost breakdowns, and site info with GPS coordinates, and assigned attestation from an authorized officer. Projects must have either 2 fast chargers, 50 kilowatts or more, available 24/7, or 20 chargers of any eligible type. Eligible costs cover everything from site design and equipment to installation and permits. NRCan responds quickly. They'll acknowledge your application within 5 business days and make funding decisions within 100 days, send draft agreements within 30 days of approval, and process payments within 30 days of completed claims. And that concludes the application process review. Now, I just wanted to quickly provide these summary tables as we've covered a lot of information, and this is an easy way to visualize that information. Please take a moment to either collect a screen capture or photo for reference later, while keeping in mind some of this information could be out of date in the near future as these programs open, close, and change quickly as demand increases. If you have any questions after this webinar regarding any of the information covered in it, please reach out to either of us, my brother or myself, using our contact information on the final slide. So this table just summarizes up the federal funding sources that we covered. Truthfully, one of our goals for my brother and I here is to be ambassadors to see more success stories in this space, that is infrastructure, EV infrastructure within Ontario, particularly level 2, as we're both EV owners. And so truthfully, if you have any questions regarding any of this information or curiosities, please do reach out to us. Okay, I just want to take a moment to reiterate some of the importance of starting the planning process sooner than later to ensure that you have the best outcome and highest chances at success of gathering different funding sources. Successful municipalities distinguish themselves from those still waiting for opportunities through strategic preparation. When funding rounds open, you must have shovel-ready projects with pre-identified sites, confirmed access rights, technical specifications, cost estimates from qualified contractors, and permits already in process. Developing comprehensive energy plans through programs like the Municipal Energy Plan Program creates strategic frameworks that position you for multiple funding opportunities. These plans become the foundation for competitive applications and should be paired with early partnership building with local utilities, experienced EV charging companies, and regional municipalities for potential joint applications. Understanding the stacking opportunities allows you to combine provincial and federal funding to cover sometimes up to 90% of project costs. Though this requires understanding each program's rules and timing your applications accordingly. Long-term planning must consider 5-year operational commitments, ongoing maintenance responsibilities, integration with broader sustainability goals, and future expansion opportunities. What does this mean for your municipality? If you haven't started planning, begin with the Municipal Energy Plan Program application. Identify potential charging sites, secure access agreements, and build relationships with utilities and contractors while monitoring for funding announcements. If you are ready to apply, prepare a comprehensive application package now. Consider working with experienced providers and have backup plans, since funding approval doesn't guarantee project completion within original timelines. For long-term success, develop a multi-year strategy that's anticipating multiple funding rounds. Build internal capacity to manage complex applications, create partnerships that strengthen your competitive position, and stay informed about emerging programs. Moving on to the next slide, we're going to cover a few emerging technologies in the EV charging infrastructure world. Okay, let's address the elephant in the room here. How do you actually get level 2 charging into dense cities? How do multiple unit residential buildings, MURBs for short, electrify their parking spots without breaking the bank? The answer lies in energy storage systems, or ESSs, and I'm excited to tell you that Canadian companies have already cracked this code. The battery-assisted solution works like this. Picture a battery system about the size of a single parking spot that takes an incoming low-voltage power source and transforms it into 50 level 2 charging stations. Where developers could previously only install 5 level 2 chargers, they're now able to install 50 without needing to upgrade the incoming electrical feed. This eliminates the often prohibitive expense associated with retrofitting EV charging into existing public and private infrastructure. But the benefits go far beyond just charging. Once you have that battery capacity, you unlock revenue generation by selling power back to the grid during peak demand times, energy security through backup power to your facility, cost savings by peak shaving to lower demand charges from power providers, and renewable integration with instant savings by adding either solar or wind to your project. Smart technology integration makes this all possible through software that actively optimizes charging loads with your existing facility power needs. The batteries act as a buffer between the EV charging demand and the grid, reducing grid impact while maximizing efficiency. Because it's modular, you can scale up as needed, allowing cities to offer scalable EV charging solutions without expensive high voltage grid connections. When it comes to solving the distribution challenge, once the power is available at your site, Canadian companies have already figured out smart, cost-effective ways to handle power distribution and circuit protection for those local charging networks. The bottom line is simple. The technology exists today to solve urban EV charging problems. While these systems have their own costs when compared to traditional electrical upgrade requirements for most EV charging retrofits, plus they also have the added possibility of collecting power during off-peak times for use during peak times, we're talking about what was once an obstacle and turning it into an opportunity. This scalable, multifaceted approach addresses one of the primary obstacles preventing widespread commercial EV charging development. For more information on the solutions mentioned here, please reach out directly to us using the contact information on the final slide. As a conclusions, the funding is absolutely there. The federal and provincial governments have committed to EV infrastructure expansion. However, success requires strategic planning through thorough preparation and realistic timeline expectations. Winning municipalities aren't waiting for funding announcements. They're building comprehensive strategies, developing partnerships, and preparing detailed projects well in advance. While opportunities are significant, competition is fierce, and the requirements are substantial. Your next steps are clear. First, assess your current readiness level. Second, begin strategic planning immediately. Lastly, prepare for multiple application cycles over the coming years. The EV infrastructure transition is happening. Whether we're ready or not, proper preparation determines whether you will lead or follow. Okay.
All right. Thank you for joining us for this webinar, everybody. We hope you enjoyed it. Our goal today was to educate on this topic, But again, we want to ask anybody who's interested in learning more, please feel free to reach out directly. We will share any information we can help in your process. And with that, I'm going to thank all of you, open up the floor for questions, and you'll see our separate contact information provided there as well. All right, that was great.
No, thanks so much, Joe and Brent. That was fantastic. I know I, for one, learned a lot, so I'm sure everyone did as well. There is one question that kind of popped up here. In terms of, and I don't know if you guys are the right folks to ask this, but obviously, if everything goes electrical, you know, all the fleets, vehicles, charging, etc., would that create a you know, an impact on our grid? Is our grid basically ready for something like this?
This vehicle, the grid would be a solution.
Well, so the short answer is the limited information I have that is the grid has the power. The problem is getting the power from the grid to the chargers. It's like been described to me once by somebody. It's like you have a lake, and that is the grid, and you need to get it to your pond, and the problem is the size of the pipe. And looking backwards, it's extremely expensive to be upgrading infrastructure. The waiting times on transformers right now in Ontario is extremely high. And this is sort of what led us to the conclusion of pushing for level 2 EV charging, which isn't a massive grid demand, also with battery buffeted technologies. But lastly, what Joel was mentioning there, and again, with emerging software technologies already existing globally, vehicle to grid back charging exists. The idea being if the grid is struggling to keep up with its inertia or seeing a voltage drop, you can actually have programmed systems that will begin to draw power back from those batteries in all of those cars, let's say a fleet network as an example, to bring strength to the grid.
And although not all EVs nowadays have that functionality, but it's being built into the newest ones that are coming out, and it will become the common standard. So if we're talking about when things are truly electrified, that functionality will be there.
But yeah, so the short answer to your question is no. Grid stability is not in question right now with the requirements for EV expansion. Yeah. Well, we have no other questions. There's one thing I wanted to just mention was the City of Brampton Public Works yard. It's a relatively new yard. I've been in there a few times recently. And I have a 2014 Chevy Volt with 365,000 kilometers on it. And I pulled in there and they have 7 public-facing EV chargers that you can plug into and charge your vehicle with. Now I noticed they were ChargePoint based chargers. So you have to have the app and the chargers are provided by ChargePoint. You bring your credit card information and you make the transaction, plug in the car. They charged me $1 an hour for that parking spot, which is almost nothing in terms of what that cost is. And what that, in my opinion, allowed them to do is offer 7 public-facing charging solutions that they don't need to manage, monitor, maintain. ChargePoint will do that, but they subsidize the costs that ChargePoint is going to charge them. So it's almost a break-even scenario without having to commit to a software solution for behind-the-fence charging or your fleet-based charging requirements. Just a different take I'd never seen or thought of before. I thought it was a really good move by the City of Brampton.
We did get a couple of questions there in the Q&A.
All right. Fire away, Joel's ready.
All right. So question number 1, when you mentioned at the beginning that EV sales increasing would drive up growth, what was being defined exactly when you speak about growth?
Well, that's the rapid adoption of electric vehicles and plug-in hybrid vehicles to start with. But the 5% tipping point was being identified as a point in which the general public starts to see more of the infrastructure and more of those cars around. And there seems to be, well, not seems, there's data showing a rapid acceleration in the purchase of electric vehicles, EVs specifically. Zero emission vehicles include plug-in hybrids, which do have motors in them and can give away, and give off emissions. But for all intents and purposes, for what I consider, if our adoption was solely switching to ZEVs and EVs, that's perfect, because the reduction in emissions on plug-in hybrids is pretty significant.
Okay, awesome. There is another question too. This question simply states residential unit sales. Not sure how to interpret this one.
Residential unit sales, okay. And great, a vague question is perfect. Answer in any direction that I want. So to talk about that a little bit, we didn't really touch on this really at all, but we're in the business of bringing the power to the charger that's going to charge the vehicle. In terms of residential sales, I have a Rivian, and they supplied the charger. I had to get it installed, and I'm hearing Rivian's new chargers will go both ways, can actually send back 22 kilowatts of power back into the house. So, and that's a 135 kilowatt battery. But to come back to that question, that's a tricky one with the sales of level 1, or what a surgery would be level 2 EV residential car chargers. But yeah, units, there's no clear front runner. The manufacturers seem to have their own, provide their own chargers, but if they don't, there's a lot of third parties that do. I have a friend of mine who has a Mitsubishi plug-in, 80 kilometers, and then also a Hyundai Ioniq 5 fully electric. And he opted to do 2 portable level 2 chargers, where he got them on Amazon. You can choose the charge rates and length right on the charger itself, but it doesn't commit him to a permanent installation. So if he's going on a trip, he can unplug those 2 chargers once he needs and take them with him. Another approach that doesn't commit you to a permanent installation.
Awesome. No, that's a good answer. So there was a few more questions. Actually, they're coming in now. So one of the questions is pretty simple. Will the slide presentation be shared? And to answer that, yes, the recording will be posted on the OPWA YouTube account, and the link will be posted on the website.
I also want to mention, I referenced a lot of websites there that had links that could help with the services. I have those links. If you email me, I will give them to you. I tried to put them in the presentation as hyperlinks, but it doesn't really work like that. One day. But we have the information in this talk. So if you have questions or things you want help with moving along, email us directly and we'll get you what you need.
Thank you so much. So we have another question right here. So what is the typical time to fully charge a standard/average EV in terms of level 1 versus level 2 versus level 3 chargers?
Like a full EV is
Let's assume 100 kilowatts battery tank. I got my calculator because I love that. That's a good math question.
Level 1's been kind of bypassed because it's so it's
52 hours for level 1.
If you're trying to use it for work, it's just not going to happen. So you have to go to level 2, and level 2 though,
you just take a 0 off that, 5.2 hours.
Yeah.
So you can take 100 kilowatts of big battery. Typical cars are 70 to 80, but you can charge 100 kilowatts in 5.2 hours at 19 kilowatts. And then if we're going to go to the big one, I mean, everyone's heard about level 3.
But that determines on the hardware in the car.
There's a lot of, and I've never successfully had my Rivian charging at level 3 speeds. Every time I go to a level 3 charger, there's some issue, some problem, whether it's the plug, whether it's the charger itself. But I think the fastest I've ever charged mine's 33 kilowatts per hour. And I mean, you can get well past 250 anyways in Canada. 350 is, it says my car can receive a charge, maxes out at 250 kilowatts. But again, in terms of timing, 20 minutes and you're going to see a significant charge, but it's different. You can't charge 100 kilowatts if you have a 100 kilowatt battery at a level 3. You can charge 80% of that very quickly, but you will leave before you bother charging the last 20 because it has to slow down its charge rate quite quickly.
And level 3 chargers are already disseminated around the province along major highways, because truthfully what they're for is for road trips. That's when you use a level 3, because you're on the road, you want to keep going and use that 80% range again within the next 45 minutes. Whereas level 2, to have it distributed more through the municipal scale, up into say Algonquin and whatnot, or more remote places, it would be extremely useful for EV owners to be able to go to a grocery store or a cafe, plug in for 2-3 hours, and get that 150 to 200 kilometers to get home, no sweat. Whereas if you take your level 1 charger with you, if you have one, hopefully you're there for the weekend. But yeah.
Yeah. No, I really think level 2 is a great solution that bridges both those worlds. Not a massive demand on our grid, but real charging solutions where you can charge your car quite quickly, unless you're on a giant road trip, which is where you want to find your level 3 charger.
No, that's a great answer too. So we do have one more question that's also part compliment. The compliment being, by the way, love the enthusiasm and knowledge you bring. So
Thank you.
Thank you. I thought it was gonna be the shirts.
kudos. I think it's a package, right? It's a package.
It's the whole package, right.
So the question itself being, this is a provocative question and off track. Good start. When you consider the mining of rare earth minerals, is electric still sustainable and viable? Curious about your perspective.
Who wants it? Who wants that one?
Yeah, I mean, that's a big question, right? You blow it up to, because then you can't just think of the car, you have to backpedal out and start thinking of power grids and where's that power coming from. And, you know, if you look at the parts going into an internal combustion car, there's still a huge amount of parts going into that, as well as the parts that go into it to keep it maintained and running. So there's the maintenance factor of an EV that's reduced relative to an internal combustion. There's the initial carbon footprint of the manufacturing of each one, which sure, the EV occupies a larger weight in terms of rare earth elements. But the amount of time that car is going to spend on the road, one, not producing any emissions, but two, literally on the road, is going to be outpacing internal combustion engines. And we're not seeing that yet because we're only maybe a decade in, you know, and at the beginning of that decade, 1-2% of the population was buying those cars. But as the used market starts to get flooded with EVs, we'll learn more about that. And as people buy used EVs, they are again actively reducing this impact of the rare earth element on extraction. And I truly believe it's hard to keep up with, but in this moment, it might seem like there's a big impact, and there is with this mining, but technology is changing so fast. Like sodium ion battery technology is accelerating, and it's a very sustainable solution. There's a lot of different battery technologies fighting for this market. And so companies, it comes back to the buyer's power. Like if you're going to support a vehicle that starts to take on a battery that's maybe more green in a sense, like they'll become that competitive market as people are manufacturing EVs. It'll be who can do it in the greenest fashion. I truly believe we're going to keep working towards that peak of it being more sustainable on all facets.
Yeah, and to Joel's point, right now, the mining of rare earth metals for lithium-ion batteries is bad for the environment. There's no question about that. But they are working hard on different battery techs, but also big leaps forward on sustainable ways of mining that lithium.
Yeah.
The last opportunity that has a massive amount of energy going into it is recycling those batteries. Mm-hmm. That's already happening, and that doesn't get talked about enough. Yeah. These batteries, we're getting to a point where we're achieving 80% of the battery can be recycled and reused. You can't do that with ICEs. So it's hard to make the argument that the mining of the batteries is detrimental to our environment when weighed against the cost to have more ICEs on the road.
And correct me if I'm wrong, but I remember looking this up at some point, and it depends where you live and what car you own, but it is based on the mileage, right? So I think if you're in Toronto and you have a typical EV, like a Tesla, for example, it's anywhere from like 65 to 100K or so, and you break even on
right.
The carbon.
Yes. I can't believe that Chevy Volt of mine with this 360,000 kilometers. That thing
many times over. Yeah.
But it's Canada's tough. We're a huge country. We travel massive distances. Mm-hmm. There's no question about that this is a real hurdle for us. But there are some real positive things happening in other cities around the world that have accomplished this goal of a giant switch to EVs. The noise and emission pollutions reduction is significant. Cities are way quieter, and you don't have that same exhaust output from those ICEs. it is something to aspire towards, but I recognize that Canada is a tricky one. We have a huge country and we drive big distances. All right. Well, I do want to say, guys, we're passionate about this. We enjoy giving this talk. And if you guys have anybody else, peers, you could suggest, hey, these two guys can give a talk, we'd be happy to.
There is one more question. Sorry, they keep coming in. But it's a good one. Have you had any projects related to charging stations at airports for aviation purposes, i.e. small electric airplanes?
Short answer is no. I know it's an emerging technology, but it's a density relative to weight density, energy density of the battery. But no, I haven't.
No, I haven't had any either. But currently, I believe that airplanes run on AC current, but at 220 hertz. They have their very own specific electrical system. I've worked on bringing power to inverters that convert that power, but no, I've had no integration with that. Wouldn't that be exciting? Even just a hydrogen possibility.
I think that's the future.
Is the future.
Hydrogen fuel cells for airplanes, but who knows? The point is they're pushing it, and how exciting would that be to be able to get on a domestic flight from Vancouver to Toronto or wherever, and it's a zero emissions aircraft. I do think it's in the future. How far off, I don't know. And how exciting it would be to be giving a webinar about charging solutions at airports for airplanes. That would be great.
But it's important to remember we're trying to eat the low-hanging fruit first. And that is 60% of the road emissions going out right now are from commercial fleet vehicles, which only account for 20% of what's on the road. That is achievable. Public charging is challenging, but fleet-based charging, there's real solutions right now that we can use. Okay, awesome. Who's going for lunch?
Thank you again.
Yeah, we appreciate it, guys. Thanks so much for listening to us talk about EV charging.
Thanks so much, Joe. Thanks so much, Brent.
Yeah.
Have a good one.
Thanks, Alex. Bye.
Everybody have a great
Bye,
Bye, everybody.
day.